So thank you, Ipek. I am going to plunge right in here and give you a little bit of context and background to the work we've been engaged in. So for those not familiar, government as the integrator, or GADI as it's called, has become really the preferred approach to doing acquisition, replacing the lead system integrator, or LSI approach that's been used in the past, in part because of some rather disappointing outcomes for some major defense acquisition programs. And as one of the things that the LSI approach brought to the table is the fact that the LSI contractor would typically have assembled a team or consortium of contractors who were familiar with one another, often had worked together previously, and were essentially known quantities in producing an overall solution. And that's not necessarily the case, and often is not the case, in government as the integrator type acquisitions, because we're looking at a best-of-breed competition among the contractors needed to produce the overall system. So what happens is that the incentives among the different contractors who are participating in a GADI team may not necessarily align even with each other, much less with the overall program objectives. And so the resulting less than optimal contractor cooperation can cause schedule delays, cost overruns, and issues with the performance of the system that's ultimately delivered. So the government is really still trying to learn how to do GADI acquisition and how to play this game, and there have been a few pitfalls as we have learned more. So where do we want to be? Well, we'd like to be able to align the incentives of the different contractors using some customized incentive mechanisms. So bring them into alignment as opposed to the situation they would be in by default. And we'd also like to be able to combine different types of incentive mechanisms together so as to be ultimately more effective. And the result of this, the intention is that contractors who are acting in their own interests will also, by default, with aligned incentives, be acting in the program's best interest, which is what everybody wants. So our approach in pursuing this is, first of all, to describe and characterize these relationships and the situation that the contractors and the PMO find themselves in using game theory. Then to take that game theory characterization and use agent-based modeling to be able to quantify those outcomes by simulating different incentive mechanisms, i.e. different ways of aligning those incentives in the context of an acquisition program model. And then when we see those quantified outcomes, be able to select the most promising combination of incentive mechanisms that becomes apparent. So let me give an example and walk through it quickly. So let's say we have a GADI program with a cost plus award fee, a contract where you can change the award fee structure every 6 months or so. So let's imagine we have two contractors, each one developing a subsystem, and the subsystems have to work together in order to produce the full functionality of the final system. And let's say there's a giver-receiver list, as there often is, describing the schedule of the areas in which the contractors have to interface their subsystems together. So from the PMO standpoint, their goal is program success. They want to see the program achieve their cost, schedule, and performance goals, and they do so by measuring the performance of the contractors, by performing the integration actions they're required to do in a GADI context, and by also implementing coordination actions, which would be various incentives to try to improve cooperation among the contractors. Now, the contractors have a slightly different perspective. They're certainly interested in achieving the goals of the program. They're also interested in maximizing their own goals in terms of their corporate success. And so in doing so, they're performing their development activities and they're reporting back on progress and status to the PMO, and that information may be more or less accurate depending on the situation. Now, so the contractors want the program to succeed, but they may also have incentives that may lead them to not prefer to cooperate with the other contractors. And the kinds of issues that tend to come up are, for example, there might be a potential competitor or an actual competitor that the contractor is working with, and they will have to disclose potentially proprietary IP to them. They may have to provide relatively costly technical support to them to help them be successful. There might be disagreements about how an interface should be structured, because an interface in a particular form might simplify work for one contractor, but at the same time make the original contractor's work more difficult. So if the contractors end up choosing not to cooperate for whatever reason, they can delay the work, desynchronize the schedule, and at the same time, when they're reporting back to the PMO, they may not be giving the full information about the actual situation happening underneath. So this is a situation we clearly want to avoid. And so what we can do is characterize this in terms of game theory. And so let's just look at a couple of very simplified examples, notional examples of that. So it can happen that the way the different contractors' motivations and incentives line up by default, they can end up in what's called a coordination game. And this is very simply a situation in which there's more or less a 50-50 chance of them choosing to cooperate with each other or choosing not to cooperate with each other. So not the optimal arrangement we want to have for the program. Alternatively, things can line up so that it forms something that's called a prisoner's dilemma. In the prisoner's dilemma, we end up with the Nash equilibrium, as game theorists will call it, or the most likely outcome being that both contractors will decide not to cooperate with one another, the worst possible outcome for the program. Where we want to be, clearly, as opposed to either of these two options or yet some other suboptimal options, is to prevent this by providing incentives to the contractors to align the incentives, so changing the game to one in which the national equilibrium is in the upper left, where both contractors decide to cooperate with one another. So how do we go about doing this? Well, there are a number of different solution incentive mechanisms that can be applied here. I'm going to be talking about a few of them, such as a shared destiny, in which all players win or lose based on the outcome. There's assigned fault, there's a risk pool, and there are other types, a number of other types that we can look at to get this job accomplished. Now, once we have an identified incentive mechanism that we want to use, or a set of incentive mechanisms, we can then move to modeling that particular game as we understand it, and modeling that incentive mechanism and doing so in the context of a fuller acquisition program model, so that we can then play out all the moves and counter moves that will be made into the future and evaluating the outcome. And then those most promising incentive mechanisms that we arrive at can ultimately be piloted on a collaborating program. So we're working now with a major defense acquisition program heading towards doing exactly this kind of thing. And then ultimately, of course, a key part of running that sort of pilot is making sure that we're able to measure, in fact, the increase in cooperation that we do see. And so there are various techniques like compliance with the giver-receiver program, EVM performance, defect counts from interface testing, et cetera. So this is basically where we're trying to go overall. So let me talk a little bit. I mentioned some of the incentive mechanisms that can be applied here. And the fact of the matter is that different types of incentives will affect different contractors to different degrees and in different ways. And we also believe that the combined impact of multiple incentive mechanisms can be more effective when you're trying to influence a broad range of contractors sufficiently to be able to change their behavior. So there are three types here. The first is future business incentives that tends to have appeal to higher level management, things like reputation tracking. We have direct financial incentives we're all familiar with, things like the incentive fee and award fee plans in CPIF and CPAF types of contracts. And a couple of examples here. One is called TRIM, the Truth Revealing Incentive Mechanism. This was an incentive mechanism that was adapted by Naval Postgraduate School for use in defense acquisition. And we'll talk a little bit more about that in just a moment. Shared Destiny, I made mention of a moment ago. In Shared Destiny, all the teams receive only as much award fee as the worst performing team gets, so everyone's incentivized to help out that team and bring them all up to a level and overall help the program maximally. And the last of the three categories are social or team networking incentives that appeal directly to the development teams themselves. One example is the use of co-location, where teams with the greatest potential for poor cooperation can be co-located to improve communication and trust and ultimately improve cooperation and performance for the program as a whole. So the point here is combining multiple incentive mechanisms so we can align the contractor organizations with each other and with the PMO's objectives, maximizing the improvement to the contract and the program. So I said I'd talk about TRIM a little bit. So as I said, TRIM is the truth-revealing incentive mechanism. And in the case of TRIM, what it really is a sliding incentive fee for cost-plus incentive fee contracts. And so it's basically based on completion date, so that the most incentive fee is received for near on-time delivery, and then it rapidly and non-linearly falls off from that, incentivizing the earliest possible delivery. So we created a model to look at this, and these were the results that we saw with over 200 simulations of a 4.5-year program. Using TRIM, we saw about 97% on-schedule performance. That's the steep green hill. And without TRIM, none of the runs were actually on schedule. Half of them ran more than a year over. So this sounds really great. And everyone probably is saying, oh, that sounds like a good thing to use. But it turns out to be a double-edged sword. So this is an example of the model that lays underneath some of this work. This is one that was created of an actual program, the program that we're collaborating with that I mentioned. And so let's take a look at some other visualizations we can get out of this that show us some of the reasons why simply applying TRIM doesn't really solve our problems. So here's an example, a visualization produced, again, through many different simulation runs of incentive mechanisms with the program model. So on the left, we have the team networking incentive, and on the right, we have the shared destiny incentive. And you can see in terms of composite program performance, we're almost doubling the performance over not using either incentive compared to using both together in conjunction. So that looks good, and it looks relatively understandable and straightforward. Now, if we look at another graph, though, things aren't quite as clear. Here we're looking at the effects, the combined effects of using the TRIM mechanism on the left and the shared destiny mechanism again on the right. And this time we see it's not the case that by maximizing the use of both of those incentive mechanisms, we get the best performance. In fact, we get the best performance by backing off on the use of them to a not insignificant degree here in order to achieve the optimal composite program performance. And the reason for this is that TRIM is incentivizing for scheduled performance by each individual contractor. Shared destiny is incentivizing cooperation across those contractors in pursuit of the common goal of the program. When you put the two of them together, they're essentially at odds, even though both are really necessary to get the kind of performance we want. And so this is the kind of feedback we can get when we analyze the degree to which we want to be using TRIM together with something like shared destiny as one example in producing the optimal result. So with that, let me just talk a little bit about the broader picture. Where are we going with this? Well, clearly, let's imagine we have a program manager who has some key questions that need to be answered, like, you know, is poor cooperation on the part of my GATI contractors hindering the program? And they could come to us. We could identify potential incentive mechanisms to apply. We could model those incentive mechanisms. We can then integrate them in the context of an overall model of the acquisition program. We can get the results of that, find out which incentive mechanisms are recommended based on those outcomes. We can then pilot those mechanisms on the actual program. We can then take the results from the pilot and evaluate our model conformance to the correctness and see their correctness versus the pilot data. And ultimately where we want to be then is we're able to mitigate the acquisition program manager's problem because he can now apply the recommended mechanisms with confidence from the pilot results and from the simulation data. So next steps, we're continuing work with the major acquisition program. We've been collaborating with, conducting interviews with them and collecting feedback on the game theory-based models we have and some of the candidate incentive mechanisms we've developed. In terms of future research, we want to actually do a pilot with them and to validate the effect on contractor cooperation. And our vision longer term is to be able to have provide a service to DoD acquisition programs where we can use what we call a virtual acquisition modeling laboratory to help program managers make evidence-based decisions based on the projected program performance that we can see in our simulations. And that's what I have today. And let me just make a shout out to my excellent collaborators, Dr. Will Casey, Julie Cohen, Andrew Moore, and Dr. Bud Mishra at the New York University Courant Institute of Mathematics. Are there any questions? Yes, sir.
Actually, two kind of questions. One's kind of short and one might not be. The short one is, the NRO had an innovative incentive model in its early days. I don't know if they still use it. And they would typically have cost plus incentive fee contracts with award fee. But the innovation was they would have on-orbit clawbacks of fee if the system didn't perform or performed suboptimally. Mm-hmm. Ultimately, we want these systems to perform for the soldiers and sailors. So have you looked at any incentive plans that actually help emphasize the importance of performance in the field?
We have not looked at ones in particular, but that's absolutely something we'd like to add into this work in the future if we can.
Okay, and then the second one is kind of a little bit of a micro version of this. Mm-hmm. Participated in a recent DSB study looking at software acquisition. One of the things, the report's not out yet, but one of the things that kept being discussed is, does DoD really incentivize contractors to use modern software practices? And there's at least some concern that DoD might disincentivize people to use modern software practices, and that may be part of the issue. Have you looked at that at all? It's sort of a smaller thing than the total acquisition issue.
I think it's a good point. We have had some discussions about this, and one of the issues with that is, of course, it likely increases the risk involved in the program, certainly in the eyes of the people working the program. Mm-hmm. So that's that may be one of the reasons why you actually see the default behavior not happening by itself. And so it would require active incentivization.
Active incentive structures,
and that's precisely what we're talking about here.
Yeah, thanks.
Yes?
Sir, in your game theory, did you introduce or thought about introducing things that were not in your control, or like requirements changes and so forth?
That turns out to be a real factor. We've done some of this work in the past in other applications, not in the GADI context, but looking at joint program and these other things. And yes, it's one of the issues of multiplying the complexity of the model and increasing the number of variables, and you head towards an n-dimensional space. So some of these are simplified a little bit, but I think it's an excellent point, and that is exactly the kind of thing that has to be done with these sorts of models.
Right, because I was involved in doing exactly this type of thing for the GPS-3 and OCX acquisition at SMC, and we got wildly diverging results on that. So any insight you can share, that'd be great.
Great. Well, we'll be available after the session, and then over at the full team, and then over at the poster exhibition this evening at the reception.
Great, thank you.
Question here.
Yes.
I think in my experience in program management, the ability to structure your contract to get the behaviors results you want is sort of a holy grail. And it's always the law of unintended consequences. You control for one thing, and the contractor will continue to find the way to maximize their profit in whatever model the government presents. So I know you realize this. So my question to you is, have you considered having an industry team, red team, your model, to help reveal where their profit, where they're going to find profit in your model that you're not anticipating?
So it is an excellent question. It's a really good point. It's something that, frankly, there wasn't enough time to shoehorn that kind of meta-analysis into this talk today, but I'd love to talk about it offline. To answer the question specifically, that is part of what we will be doing with the program that we're working with, because we want to be talking to the contractors for that program and elicit, to what extent we can, exactly that kind of information and their perceptions of that. I would say at a larger level, one of the key points in this is that basically, like any situation, there's an ongoing escalation in terms of technologies. You introduce a new technology, a new incentive plan, and there's going to be a response to that that figures out how to either defeat that or take better advantage of it. And you have to continue that sort of thing. And one of the aspects we've looked at along those lines is evolutionary game theory as a way of trying to game out some of that. Even though you can't predict exactly what those innovations will be, you can say something about the progression of that innovation over time and how that affects the overall ability to incentivize the behavior you're looking for. So, excellent question.
Question.
Yes.
So once you've determined that shared destiny helps, I'm trying to understand why you would need to develop a further model, because you're that focus on, okay, I got to focus on my contracting to incentivize the contractors. The contractor, a large prime, typically have shared destiny with small contractors, right? Small companies, that's part of their team, because if a small company flops on a piece of hardware or software, the prime suffers. So the prime has an incentive to help the little company to get their feet back up. So I see this as probably focus on two large primes having a piece of award share. Sounds like this is what you're focusing on, the MDAP. Right?
Yes, that is an aspect of that program.
Okay.
Sorry.
But once that's kind of defined, okay, you understand what the shared destiny in terms of contracting needs to be done. I'm trying to understand what additional information you could gain by having this model.
Okay, and I think, you know, one thing to say there is that this was the original problem we set off to scope this down to be narrow enough that it's something that we could tackle in essentially the one-year time frame that we originally were funded for, that we have been funded for up to this point. And so what we would very much, I think, be interested in doing is exploring other problems as well. So the GADI problem is one that's timely, it's of interest to a lot of programs, and figuring out how to work those issues. But as we indicated, you know, shared destiny isn't always the right answer, or the degree of shared destiny is not always clear. So that's part of what the analysis is trying to tell us, I think. Yes,
So
sir.
the question, it was interesting because the way I interpret, and you know, my internal voice is, instead of contracting for capability or services, you're suggesting that the government contract with other organizations that are for profit to achieve end goals, which is kind of how I kind of parse that information. For that to happen, you talk about, you know, risk being a concern and program managers being risk averse. What kind of policies do you think that DoD should look at implementing to sort of parse that out to say, okay, here are the risks you should consider taking in a partnership given these potential controls based on these potential outcomes? It seems like you should be able to point out specific behaviors or other things that we could actually start training into folks and ensuring that we're properly resourced on the government side as well as, so we can be good partners. So how are you heading towards that, and how would you head there?
That's where we absolutely would like to go. I mean, there are clear applications of this kind of technology and the modeling capability in terms of doing analysis of policy a priori, to look at a number of different aspects and not necessarily, you know, just the issues we're looking at here. So it's probably a longer discussion, and I'm being given the hook, as it were. But thank you very much for the question, and as I said, we'll be available this evening also. Thank you very much.